sure this turned on.
At the start of each lesson, especially after the first one, first thing I'll take is homework questions. Because I think you had a question? Okay. Because again, if you do have a question on one of the problems, we will go over it. I'll go over it here. We'll explain it in more detail or kind of answer the question that you have on it. So if you got them done, awesome. If not, you're not sure or want a question on it, ask. We'll go over it right here. Because I'll go over one or two of them, and then we'll move on with the lesson. If there aren't any questions, we'll move on. All right? Now, what we're talking about today are parent functions and transformations. Parent functions and transformations. Now, there are different transformations that we can have and we can apply to a function. And there's four main parent functions, or really three, that we're going to talk about with these transformations here. Linear, absolute value, and quadratic. Now, constant, we can apply transformations to it. It's just a line. It's just a number. So there's not a whole lot we can do to it. We can move it up. We can move it down. And that's about it. There's really nothing else we can do to it. Linear and absolute value and quadratic are the main ones we're going to focus on. Now, these are the parent functions. And the reason we call them the parent functions is because all the transformations and other functions, not transformation, but the other functions, other linear, quadratic, and absolute values come from this. They're all going to look the same. These are just the most basic versions of those functions there. Okay? Questions on this so far? Now, y'all dealt with linear absolute values before because you've done a lot of linear equations in Algebra 1. Because 7x plus 3, 1/2 x minus 2. All of those are linear. They all look the same. They have this straight line. And we have just this x. The absolute value are all going to look like a v and have the absolute value sign. So that's kind of the giveaway for it. And quadratic, we know it's quadratic because of the power of 2. That's square. Is why it's a quadratic function. Okay. Now, as I said, we do have different types of transformations. That's how we get all the different functions. We're transforming them. We're manipulating the parent function to make it look a little different. Linear. Quadratic. Absolute value. These are the three main ones we're going to look at. We don't look at too much at constant because constant is either going to move up from 1 or down. That's it. It's either up or down. So if we have f of x, well, I'm going to add this. You don't have to write this because the parent function, f of x equals 1. And if I said we had f of x equals 4, well, what changed? It went from 1 to 4. We added 4. We went up 4. If I went from 1 to -1, we went down 2. And it'll make more sense when we talk about it, but it's really, we just changed the number. There's not much to it. That's why I'm not too focused on it, because either a bigger number or a smaller number. That's it. So we're mainly going to focus on these three. Now, there are other types of parent functions because we have cubics, x cubed. We have radicals, so the square root of x, rational 1 over. There's many, many other types of parent functions. We're mainly focused on these three. Okay? Now, what we're going to write underneath each of these is the general form. So the general form of the function. So for linear, a parentheses x minus h close parentheses plus k. This is the general form. So this here, given a value for a, h, and k, we can make any type of linear equation that we want. Now, it could be that h and k are both 0. We don't necessarily have to have a specific value for it, because if it's 0, we don't write it. Because plus 0, no reason to write plus 0 or minus 0. And a is either going to be 1 or a number. Yes. Well, we don't write a multiplication of 1 because it makes 1 times x, we just write x. So if a is 1, h is 0, k is 0, we're just back at f of x equals x. It's the parent. Quadratic. F of x is equal to a parentheses x minus h squared plus k. Looks kind of similar to how we wrote the linear, yes? But it's a quadratic. We have that square, that power of 2. Absolute value. An absolute value, see, that's kind of a similar form too, yes? A, H, and K have different properties to them, different transformations, different things that are going to be applied to the function itself so that we can know how it's going to move, how it's going to change, how it's going to differ from the parent function. Now, the main reason I find this helpful is this is good to go over. It gives us an idea of what the graph is going to do. Because the absolute value function, we know it is a V-shaped graph with the bottom of the V at the origin, yes? So if I'm able to tell that the function moves 3 units to the left, well, I can picture, okay, I have an idea of what it looks like. Or if it's reflected, or if it's stretched, it shrinks. This here helps us give us a picture of what the graph should look like, what the function should be doing. That's the key. Because if we can get a good idea of what it should be doing, we know what the solution should look like or what kind of outcome we should have. It gives us an idea. Now, I'm not going to stand up here and say that because graphing is a part of this and that graphing's key and is crucial that we should always know 100% how to do it. It's helpful. It's good to know. But unlike 10 years ago, we have so many resources that can do it for us, yes? Because I remember, I think, especially in middle school, high school, having math teachers tell me you'll never have a calculator in your pocket wherever you go. I mean, you could, but you're carrying around one of those or a graphing calculator. Because the phones I had were great if they took a 6 megabit picture in black and white. It was my first phone. So, again, it didn't have anything high-tech as what we do now. The phones we have now can do whatever we want. It can graph, it can do whatever. It can actually calculate a lot of this stuff for us. So I don't see a whole lot of reason to spend a ton of time making sure we know 100% how to graph. If we have a picture and understanding of it, that's great. Clear these out. Because this here is the graphing calculator. I do have one of them up here on the board. So the ones that you'll have over there, I'll put them out here eventually. I keep saying that. This here is the same thing. So when we start using this and actually going over how to graph and plug it in, y'all can follow along with this here. So that's going to be helpful, especially as we go through the lesson so that you're knowing and getting familiarized with using this. But, so y equals x, f of x equals x. It just graphed the equation line. So why do we need to go in depth over it if this thing will do it for us? All right. So that's about graphing. Now these three here are our basic forms. A, H, and K do have a specific function. When we have a value in those spots, it will move the function, move the graph in a certain way. Or stretch it, shrink it, flip it. Move it left, move it right. Stretch it up, stretch it down, stretch it horizontally, vertically, shrink it in any of these different ways. All right. Now, transformation, so we're on the back of the first page, changes the size, shape, position, or orientation of a graph. That's just transformations. Translation is a translation is a shift of a graph horizontally or vertically, left, right, up, down, but does not change the size, shape, or orientation. All we're doing is we're just moving it up, down, left, right. We're not changing anything else about it. All right? Now, as I said, with this here, these values, A, H, and K, do have a purpose. H is the first one to look at. Now, in the past, I've written it under each one. Thank you. Okay. It's textbooks. Have a specific name, and I would write under each one what it does, because H is going to be our horizontal, our left, right. So I'd write left, right, left, right, left, right. Again, remember once we get partway through, it gets messy, because again, we're going to have something for all three. So if you want to write under each one that is going to move left, right, that's fine. But what we can also say is H colon is horizontal. Translation. It moves it to the left or right. I'm just going to put it underneath, because each one of these, linear, quadratic, absolute value, is going to do the same thing. So whenever we have a value in that H spot, inside those parentheses, it's going to move that function to the left or to the right. It's going to move it in one of those two spots. If there is no value inside the parentheses or absolute values, that function is not moving left or right from where it started. Okay? K is our vertical. Translation. It's going to move it up or down. It's going to move the whole function up, or it's going to move the whole function down. That's it. And the number that goes in each one of these spots is going to tell us how far it's going to move up or down or left or right. Questions on this here? We're ready to look at one. Because, I mean, looking at this is fine, but it's sometimes better when we can see an actual example, something to connect it to. Do we have this copy down? Yes? All right. So we have this first one here. Graph g of x equals x minus 4 and its parent function. So if we're looking at this, just the parent function, what would the parent function of x minus 4 be? Because we have four. We have constant, linear, quadratic, or absolute value. Which one of those four do we think it is for x minus 4? Anybody have a guess? Huh? It is linear. Because we just have x by itself, yes? Absolute value functions have what? Absolute values, yes? This one doesn't have absolute value, so it's not an absolute value. Quadratics have an x squared. They have that exponent of 2, yes? Does this one have it? No. So it's not quadratic. If it's constant, it's just going to be a number. There is no variable. So it is linear. Also, whenever we just have an x to the first, that term is called the linear term. So even if we had an x squared plus x, the x squared would be quadratic, the x would be linear. So this is linear, because it's always defined by the biggest order for these polynomials. Because the 4 is technically linear or constant, but the x makes it linear. If we had an x squared with it, it would make it quadratic. Make sense? So this is linear. So we want to describe the transformation. For these first two, we're going to look at it graphically and then algebraically. So graphically, linear, this is the linear parent function, yes? Now the new one we have is x minus 4. Now again, we'll go over how to type this in. We'll do that at a different later date. What I'm mainly wanting to look at is the graph. So the one in red is the graph of this here. So how did it change from the blue to the red? What happened to it? It went what? Yeah, you said it. It moves 4 spots. Which direction did it move 4? Kind of right or down, one of the two, yes? We'll say down, because it is moving down 4, because it started at 0, 0, and it's now at 0, 4. It was at 4, 4, now it's at 4, 0. So this here moved, its transformation is down 4. That's the transformation. Its parent function is linear, and it moved down 4. All right? We're ready to look at this algebraically as a function. Now, the generic version of linear, f of x is equal to a times x minus h plus k. That's the general form of this here. Now, do we have parentheses written for g of x? Well, no, just x, right? So there is no value for h. Not moving left or right. H is left and right. But do we have a value for k? Well, yeah, the minus 4, yes? So 4, the value of k is 4. So that's where we get the 4 from. And since it's negative, it is going down. If it had been plus 4, it would have been going up. We can see that graphically, because here, well, I need some other color than red. Moved it up 4. We good with that there? So that makes sense, yes? All right. Let's look at the next one. Which one is this parent's function? Absolute value, yes? And most of them I can read it out and then we can kind of go from there. This one, it kind of gives it away, doesn't it? Because the absolute value of x plus 1, what's its parent function? It's absolute value. So the absolute value y'all should recognize this calculator because we are going to graph it, but I do want to pull this one up. So I will be using both of these throughout the year. And I believe Ms. Kendall, and I've said it before, can we do the absolute values on this thing? Like actually type absolute value in? No, I mean, we can get it simplified and then we've got to correct the sign and go from there. Clear that out, clear that out. The graphing calculator can do absolute values. So it's nice, it can do a whole lot of stuff, but sometimes the 30XS, the yellow one does, you can type stuff in faster. You've been using it longer. But our parent function is absolute value of x. It will graph it. Now our new function, x plus 1. Okay, so I'm going to grab the graphing calculator. And again, I will go over this. We will go over how to get all this stuff and type it in. X plus 1. But how did the graph change? It moved to the left. How far? 1. Okay. Go. Left. 1. That's doing that graphically. Let's look at it based off the equation. F of x equals a times the absolute value of x minus h plus k. Now, am I going to make you write that every single time? No. If you do find it helpful to put them right next to each other so you can compare them and see what connects with what, do that. If you don't find that helpful, you don't have to. So again, if you find it helpful, do it. If not, you don't have to. Now, if we look at this here, is there a value or a number being added outside the absolute value? No. So that means it's not going to move up, it's not going to move down. We saw that already, yes? However, there is a number inside the absolute values, yes? So that's our h. So it's telling us it's moving to the left or to the right, yes? So the amount it's moving is how far? 1, because it's 1 there, yes? Now, would we move to the left or to the right? Be to the left, yes? But what's our number in here? What's the sign? +1, yes? Which direction is positive normally? But the graph told us it was to the... That's odd, isn't it? Now, I pull this out because, again, that is a normal mistake. That's normally what we do because we see plus, we think right. But let's look at the general form. It is what? X minus h. What's the only way, especially with plugging these numbers in, that I can turn a negative to a positive? Is with another negative, yes? So the value of h here is not +1. Because really what this is saying is that we have x minus -1. Because the negative and negative make a positive. Because we don't normally, we're not going to write negative. There's no reason for that. We'll just write it as +1. So here the value of h is actually -1. So that's why it's moving 1 unit to the left, not 1 unit to the right. Okay? So this is one way we can look at these here. The other way, the main way, that I'll probably end up saying it time and time again, whenever we're inside parentheses or absolute values, it's the opposite direction of what you think. Plus, we normally think right, but it's actually left. Which means is if it was -1, you think it would be to the left, but it's actually to the right. Outside of parentheses or absolute values is exactly what we think. Because the last one was plus or -4, down 4. If it was +4, it's up 4. It's exactly what we think. Inside these parentheses or absolute values, it's going to be the opposite direction. And that's actually true for horizontal stretch and shrink. Horizontal stretch and shrink, for the one that looks like it's stretched, it's actually shrink. And when it looks like it's supposed to be shrink, it's going to be stretch. It's the opposite. Inside those parentheses is the opposite of what we think. The only time it's just reflection, then it sticks with what it is. But left and right, it's going to look the opposite. Because if it's +1, it's left 1. If it's -1, it's right 1. That makes sense? Okay. Questions on this so far? We're doing good on time. All right. So we understand how this works, yes? Okay. But we'll move on. Reflections. Reflection is a transformation that flips a graph over a line called the line of reflection. You all have done these in geometry, where we have the line we count over and redraw the shape on the other side. Line of reflection. Now for us, algebraically, there's going to be two. We're either going to reflect across the x-axis or the y-axis. One of the two. Now for the most part, just our absolute value function, reflecting it across the y-axis is not going to do a whole lot. Because y-axis, it cuts it in straight up and down the center, yes? So what it's going to do is it's going to take all the points that are on the left side of the y-axis and put them on the right. And all the points on the right side of the y-axis are now going to be on the left. And it's one thing to say it, math, -x. I just reflected it across the y-axis. It flipped onto itself. So it doesn't do a whole lot with the basic function. But reflection across the x and y-axis, there is a way for us to tell it. We're going back to this here. Reflection across the x-axis is going to be attached to our A. specifically not the value of A. So if A is 2, 3, 5, 1/2, 1/5, any of those, that's not what it's doing. If A is negative, if the value of A is negative, if the value of A is negative, specifically negative, it is a reflection. So if it's 2, just positive 2, there is no reflection. It is specifically the negative. If the value of A is negative, then it's a reflection across the x. If the A is negative, A can be whatever it wants because the number is not attached to the reflection, the sign. If that number is negative, it's a reflection. If it's positive, it's another thing entirely. Because if we're looking for a reflection across the x-axis, that A value has to be negative. Because if A is 1/3, positive 1/3, there's no reflection. It's just 1/3. That's going to be dealing with vertical stretch shrink. And we'll talk about that tomorrow. The A value being negative is what gives us that reflection. So A value could be 2,000. If it's positive 2,000, there is no reflection. If it's negative 2,000, then there's a reflection because of the negative, not the 2,000. Does that make sense? Because it's very easy to get those switched. It's purely focused on the negative. Now, the y-axis is going to be inside those parentheses. If the sign in front of x is negative inside the parentheses. So we can add this. You don't have to add this in. I'm going to add it just for a second. So where that B would be, that spot, if that is negative, then it's a reflection across the y. So if that location is negative, then it's a reflection across the y-axis. Outside, it's going to be x. Inside is y. So these next two might be pretty easy because they essentially are the same thing. The first one is the graph. Our graph is p of x equals negative x squared. Well, what's its parent function? Quadratic, quad. Quadratic. Do we have an h or a k value for this here? No, because there's nothing being added outside. There's no parentheses with something being added or subtracted inside. H and k, technically we do have them. They're both 0. So there is no movement left, right. There's no movement up, down. The only thing we have is the negative side in front of x squared, yes? So it's telling us the value of a is negative. So it is a reflection across the x-axis. That's it. All right. Now, if we look at this graphically, because we can do this too, I can pull the graph up. Y equals, we'll clear those out, x squared. There's the parent function. So x-axis, right there. So if we reflect it across it, it should go from up to down, yes? Let's verify. It did reflect it across the x-axis. And that's what we said it should do, yes? All right? So it is a reflection across the x-axis. Questions on this here? K of x equals negative x. What is its parent? Linear. Again, no h and k. But the value of a, or the sign with a, is negative. And since it's negative, we have a cross the x-axis. That's it. Now, the interesting thing with the reflection across the x-axis for linear is when we have them both graphed, it ends up looking like an x. Because the blue one that's on the left side of the y-axis is now going to go to the top, and vice versa. It just flips it. Questions on this here? All right. Let's look at these three here. First one we have g of x equals x plus 3. What's its parent? Linear. So just looking at it, if I didn't write the general form, what would we say the transformation was? So up, down, yes. So we have a times x minus h plus k. So the 3 is the big change from the parent, yes? So we have plus 3. So that plus 3, does the 3 attach to the a, h, or k? Almost, because it wouldn't be the h, k. Because h is a tempting choice, and yes. But the main thing we need for h is parentheses. Parentheses are absolute values. H is always going to be inside parentheses or absolute values. So the 3 is k, yes? K, is it left, right, or up, down? So k, is it attached to our left, right, or our up and down? So we can look back. Let's see. K is our up, down. Inside parentheses is left and right. Inside absolute values is left and right. Outside, when we add or subtract, is up, down. So since it is positive, it would be going up. How far? 3. Up, down. Outside those parentheses or absolute values is exactly what it looks like. It'd be up and down. Inside, our left and right is opposite of what we think. Well, hey, we have one right here. So number 3. Before we get to that, is it linear, absolute, or quadratic? Quadratic. I'm going to write the general form. So our 2 is connected with the h, yes, because it's inside. So how far are we moving left or right? 2, yes, because the value of h is 2. Now the question is, are we moving 2 units to the left or 2 units to the right? To the right, because again, left and right, inside those parentheses, it's the opposite of what we think. Because that minus, we're used to minus being left inside those parentheses. We're going to the right. Clear as mud? Questions on any of this so far? Have you all heard clear as mud before? Yeah, that's kind of the joke. Mud's not clear. So clear. If something's clear, you understand it, you can see through it. Clear as mud, it's kind of contradiction. I didn't come up with that. Someone else did. Any questions on these here before we look at the last one? N of x equals negative absolute value of x. Well, this is what? Absolute value. I have no idea who that is messaging me, but we'll find out here in a minute. Now, we need to determine what is the transformation. Now, I'll write the general form. A, x minus h plus k. This can be quiet now. So, do we have a number that would go in the place of h and k? Well, no, I mean, it's 0. There's nothing there. The only spot we have is that negative, which would be attached to the a, yes? If the a is negative, it's a reflection across the... I do have the question every year, do we have to write across the x-axis? Well, yes, because we do technically have across the y, so we do need to distinguish between the two. So reflection across the x-axis. Questions on this here? We are going to stop there for today. And we're going to finish this